The next thing I want to do now is relating phase difference to wavelength and period. So if you have a wave like this, and you have something like this, and this is a graph of displacement in meters against distance covered by the wave in meters. So let's use the previous one. I'll use 0, 8, 16, 24, 32, 40, 48, 56, 64. And we are asked to find the phase span between point B, which is at the distance of 12, and point C, which is at a distance of 18. How do you do it? Using the distance covered by the wave. I can easily relate phase difference to distance difference, because I know that this is 0, this is 90, this is 180, this is 270, this is 360. But I do not know what angle is this exactly, and I don't want to use the grid system in which I can know the angle corresponding to the smallest division, as I've explained before. So what do I do? Phase difference of 360 degrees corresponds to one wavelength. If this is a time axis, that phase difference also corresponds to one period. So I can say phase difference of 2 pi radians, phase difference of 2 pi radians corresponds to one wavelength and one period. Therefore, phase difference of having an unknown phase difference, let's say delta phi, will correspond to a distance difference of delta x. An unknown phase will correspond to a distance difference of delta x, and of course time difference of delta t. So I can say that the unknown phase difference delta phi over 2 pi radians must be equal to the distance shift between the two particles of delta x over one wavelength, and also equal to the time shift between the 2 points of delta t over one period. Is that okay? So I've related phase difference to distance difference and time difference. The distance difference between those 2 points will be a fraction of one wavelength, and the time difference between them will be a fraction of one period. Just that the phase difference between them will be a fraction of a complete phase difference of 2 pi radians. So if I now want to find phase difference between particle C and particle B, so I can say that distance difference between B and C over one wavelength must be equal to phase difference of 2 pi rad. I say phase difference of 2 pi rad. It must be equal to phase difference of delta phi over 2 pi rad. Okay, so the phase difference between those 2 points of delta phi will be equal to what? Distance shift between those 2 points over one wavelength multiplied by 2 pi rad. In this case, the distance shift between those 2 positions is 18 meters minus 12 meters, which is 6 meters. The wavelength is 32 meters. You can see that I did not bother to put unit because this is a fraction, so unit will cancel out. Multiply by 2 pi radians. So if I do this, I can say that if you divide this one by 2, 2 in 6 will give you 3. 2 here will give you what? That is 16. Another 2 will give you what? 8 here. So this becomes what? 3 over 8 pi radians. And if you want to put it in degrees, pi radian is just equal to 180 degrees. So I just have 3/8 times 180 degrees. That is it. Okay, so with that, you can easily use the distance shift, ratio of distance shift to one wavelength will be equal to phase difference over 2 pi radians. The same thing applies if this is a time axis. If this is a time axis now, I can find the phase difference between these two positions. So this will be the period. Remember, this has to be a time axis for this to be period. So this will be the period. This will be 18 seconds minus 12 seconds over 32 seconds is equal to phase difference between those two positions over 2 pi rad. So it will give me the same thing. So there I can now express it as the phase difference will now be time difference between between the two positions over, I can now write it as time difference between the two positions over one period multiplied by 2 pi radians or 360 degrees. That will give you the phase difference in terms of period or phase difference in terms of wavelength, because we have been able to express the distance shift as a fraction of one wavelength or the time shift as a fraction of one period.